Hey everyone, how's it going? We're gonna be doing more PyTorch today. Oh wait, let's pull this little dialog box. Okay, there we go. Okay, ready to go. Hey, it's Monday. Okay, so the plan is we're gonna become PyTorch experts, right? So that means that we're gonna go through all the tutorials. Hey Jinlu, good to see you. I saw your test message. What was that? What were you testing? What were you testing? So we're going through all the PyTorch tutorials. We're gonna learn some new ways. You're cooking in the kitchen. Oh, really? Oh, nice. Very nice. What's for dinner? What's for dinner? What are you making over there? All right. So let me see here. So we're gonna start moving through this. Old. Oh, ID. Oh, look at this. There's something ID. Hey, how's it going there, Study Channel? How's it going, Study Channel? Hey, Steven, hello. Welcome on in. Happy Monday. We're going to become PyTorch experts. That's the plan for today. We're going to learn what this ID is. I'm not familiar with this. Is this something Python specific? Immediately, I did not think this was going to happen. Straight off, we learned something new. Without any fail, something brand new. Or what file is this? This is going to be called the new tensors. Okay, we're going to make a new file here. Close that. All right. Tensor today. Tensori.py. Let's just do tensori.py. That's easier. You're Praveen Patel. Oh, if you remember, we recently connected on LinkedIn. Yes. Pranav Patel. Pranav, hey, good to see you. Welcome on in. Good to have you here. We're going to become PyTorch experts. That's the plan. I'm really excited about this. All right, so import torch. We're gonna look. Hold on. Wait. There's something new we gotta try. We gotta try this out. Python ID. What is this? It's a built-in function. What does that do? I've never needed to use the ID function in Python before. Hi, buddy. Hey, Goko. Good to see you. Goko, welcome on in. Oh, hey, Sergio. Thank you for the GGs. Oh, thank you. The 20 joules. That's fantastic. Oh, brand new things are happening all of a sudden on Monday. I would not expect that to be the case. You're testing an emulator front end as that has Discord integration, and apparently it worked. It sure did. It absolutely did work. Thank you again, Sergio. I appreciate it. Very nice. So have you guys heard about this? What is this? dir ID. What is that? What's the ID function? What about dir? Can you do this? What? You sure can. It's identical. Okay. So what is the ID function in Python? I've never seen this before. This is unusual. All right, hold on a second. What is the ID function in Python? What is that? I don't know. All right, what do we use it for? All right, so blah, blah, blah. Built-in Python function that returns an integer identifying the object. So maybe like some sort of reference. Okay, so it's every object in Python has an ID apparently. Did you guys know that? I've been using Python for a decade. For maybe 2 decades now. I didn't know about this ID function. I've never needed to use it. Not even once. This is crazy. Okay. So. All right, perfect. We're going to figure this out. Okay. A is equal to B, true, because it's the same object. Oh, so this is how they track everything. Okay. It's mainly useful for checking object identity and not value equality. So you can tell, okay. So this is gonna allow, what? Okay, so this is just gonna be an ID though. It's just gonna be an ID. So let's try it out. Okay, so A equals just some array, right? A, but with the ID of arrays. Oh, look at that. What about B equals, we'll do another array. It's identical, but it's gonna have a different ID, right? ID B. So it's gonna be completely different. You sent a screenshot of the emulator front end I was talking about in general. Oh, I'm kind of curious about this. We're gonna check it out. So the IDs are very similar, just off by 1,000. They're off by almost 1,000. That's interesting. Pinned Jinlu. Okay, test. Oh, yeah, okay. Oh, right there in Discord. Okay, got it. Did you integrate Discord directly in your game? Is that what you did? That's awesome. Let me do a fire emoji. Okay. This is neat. I've never needed to use the ID before. Howdy, how's it going there, Bunzoopy? Welcome on in. Happy Monday. We're going to become PyTorch experts. We're continuing on the PyTorch trend. All right, so we just need to go through and look at all these tutorials. We're going to learn everything in the tutorials. Then we're going to start building some things. Well, I didn't make the app. Oh, got it. It was integrated natively. Got it. Okay. So they're probably using Discord APIs and things like that. It's Monday. You're sure right. It is. Wow. It is crazy that it is Monday already. Why? I wanted it to be the weekend longer. I needed more weekend. That's what I needed. Okay. So apparently you can use this with any object that you want, any class. The old ID. What do you mean old ID? Wait. Out equals C. Is there going to be a new ID? Make sure that our ID, our new C is the same object as the old one. Okay. Let's mess around with it. This isn't necessarily a PyTorch thing that we're currently looking at. This is a Python thing. This is not a PyTorch thing. This is a Python thing. All right, so A equals torch.rand. Rand, and we'll do 2, 2. B equals torch.rand. 2, 2. Torch.rand. All right, what do we got here? Oh, yeah, okay. So, see, ID of C equals ID of C. And then we're going to print this. How about we use an F string? The C equals. There we go. Then we're going to run, it's called the Tensor. Okay, Python Tensor. And we should see what? Oh, wait. I was like, no, that can't be right. Okay. There we go. All right, so the ID of C is that number right there, which is a big number. Some ginormous number. Go. I had a really bad day because I gave an interview. Oh, you gave an interview to one company that literally rage baited you. Uh-oh, that's not good. I don't know why. The interview was flexing his 10 years of experience to me. Oh, really? Well, usually it's to sell both directions, right? So they have to sell you on their team and the company and what the day-to-day is going to be, and then you sell them on you and your capability and how you'll be a good fit in that culture. Although if what they're doing is just rage baiting you and they're flexing their 10 years of experience onto you, that doesn't really seem like a healthy environment to go into anyway. The role you applied to was intern. Oh, what? Oh, come on, really? They didn't need to flex on you like that. That's unfortunate. like great. Yeah, I know you've got a lot of experience. I just want to get into the door here and I would love to work with. Well, maybe they're trying to say, hey, we've got a lot of experience and we want to work. If you come join us, you will get a piece of that experience and we'd like to share it with you. Was it like that? Or maybe were they saying something different? Because they might have been saying something different. They might have been saying, we're so good and you're not whatsoever good. You do not come close to our level of experience. Why would we ever accept you here? It really depends. It could go both ways, right? All right. No. Okay. I don't know which way. I don't know which way you have to explain a little bit more because I gave 2 options there. Okay, so let's pop over here. Okay, so we got our ID, print C. Yep, let's do print C. So we know what that is. XP. We'll also do an F string so we know what's going on here. Equals, close bracket. Okay. There we go. Okay, so yeah, we're good to go there. It would be nice if we did a torch.manual seed. We set it to 1. So that way it's the same every time, right? Yeah, nice. All right, perfect. Cashier job for 20-year-olds requires 30 years of experience. It sure does. Because there's no need, right? Exactly. They're expecting an experience like a CTO of PubNub. Oh, for the intern. That's just so terrible. That's terrible. How is it going to ever work? We need to change that. Hey, at least I can tell you at PubNub when we had interns, we did not require you to have that level of experience. I promise. You come in at any level of experience and it was good. And then, of course, if you didn't know how to use Bash, we would razz you a little bit. You don't know how to use Bash? How could you possibly be in the computer science realm? This level of experience. Bash using ZSH. Nice. Yep, there you go. That works too. It's a Z shell, it sounds. Driving and watching Steven. Hey, Dina! Be careful with driving. Just pay attention to the road. You can listen, just don't look too much. Don't look too much. Good to have you here, though. You use both. Oh, Bonzupi. Nice. Yeah, very nice. I like ZSH. I also like Bash. They're both. There's a little bit of difference between the two. Like the time function, is different between the two. How variables are treated, the true false, there's a couple other things. I don't remember. Oh, how subshells are executed, slightly different. Difference between the two. All right. La la la. All right, we'll do a mat mult. All right, so D equals to, how would we do this? Instead of doing a mat mult like this, we have to do it like this. Okay, torch dot mat mult A comma B will out equals C. Okay. And then we'll reprint these guys to see what's going on here. Let's see what that does. What if I saw is correct? I'm gonna be using regular SH for old school. Oh yeah, okay. You could do that too, just regular shell. Nothing fancy, just the very bare minimum. You probably manage though. You'll manage perfectly fine. You sure will. All right, so this is the same. So it's the same object. So we are actually doing object updates by reference, which is very neat. I didn't know you could do that in Python. I did not know that you could do by reference mutation. Well, I mean, I guess it was I've never needed to do a mutation like this before. It's just not something that I'm used to doing. I always do immutable as much as possible. Rin in Python, it turns out you can do mutation just like this. And it definitely did work. And it's the same object ID, because you can see here is the same object ID, right? Between these two numbers, identical, right there. Adarash, how's it going? What are we doing here? We are becoming PyTorch experts. Join me, let's do it together. Let's become PyTorch experts. Right now, we are looking at the ID function. Apparently, you can use PyTorch to mutate an existing tensor, which will completely replace it. Just like that. So you can see how we have C out here, and then we've got the reference ID, which you don't need. This is just, something that you could use to check. Allows you to do a full overwrite. So it's going to be a completely new matrix right there and right there. Pretty interesting. That is pretty neat. Oh, wait. There's some asserts here. Let's try this. Okay. Test C and D are the same object, not just containing equals values. Okay. So C and D should be the same. All right. This is actually neat. Check this out. ID of D. And we'll do the same here. So this will be D and D, like that. Okay. Let's try this. Let's check this out. Becoming PyTorch experts? Yes, exactly. Yeah, exactly, Bonzupi. All right, we are going to, okay, so C and D are identical now. But, and they've got, wait, whoa. D is a reference to C. Look at this. There are the same number. D and C are now the same. They are the same object and the same value. They're identical. Can you do the same thing? What if we do E? Oh, E equals C. Can we do, E equals C. Can you do this? Let's try this. This is neat. We're in a whole new world today. Hey, Kyle, I saw your message on Discord. You sent a whole bunch of text. You said, I have one slot on Wednesday where we potentially could chat. I have to move a meeting to make it possible. It's the only meeting I can move. Otherwise, there's a calendar link I sent for you. We can connect. All right. So we're gonna check this out. We're gonna see if this works. All right. So is the E also the same? I'm very curious about this. All right, is E and C and D all the same? Before I do that though, I'm gonna do that over here. I've got an idea right here. Wait. Delete that, and then we're gonna bring it over here. Perfect. All right. So wait. Yeah. Okay. That's good. Okay. Looking good. All right. Let's print that and see what's good. Not a PyTorch expert. I really need to be here. Hey, yeah. If you want to learn a smidgen of PyTorch, that's what we're doing today. You're a very busy guy. I appreciate your time. Yeah, no worries. Yeah, absolutely. Looking forward to connecting. They're all the same. Look, E, the same value, all the same value. Look at that. It's exactly the reference to the exact same object. Learning some new things today. All right, let's do some asserts. C is D. Oh, check this out. Assert C is D. All right. Assert. Okay. Test C and D are the same object, not just containing equals values. Okay, try that. And nothing should happen. All right, no errors, no problems. All good to go. Also, we should be able to say E is C and E is D. We should be able to assert all those things, right? Pretty sure. Yep, no crashes. However, if you do this, you can't say A is E. That'll fail. Hello, Stephen A. Kevin McAllister. Good to see you. Welcome on in. Happy Monday. We're becoming PyTorch music. You love the music. Nice. Good to hear it. This is just good old YouTube studio audio. It's the Creative Commons audio. For the most part. There's a couple of mixed in songs there that I might have to. I have it on the free. I have it on the free mode, so we should be good to go. In dependency hell, trying to get PyTorch CUDA set up in a Nix shell right now. Oh, yeah, Bunzoopy, it can be a challenge. I've run into many problems. It really is. It's really rough, especially with NVIDIA and CUDA. Oh my God, a big mouse now too. Oh yeah, you can see the mouse cursor a little bit easier. I made everything bigger, so that way it's easier to see on stream. So you've got a keyboard here. You've got the zoomed in terminal window. Everything's a little bit bigger. To be fair, you could make PyTorch music. I'm sure you sure can. That's actually, we could make a music generator. That would be fun. Should we make a music generator? I think we could. It might take a while. It might not make really good music. It might not make very good music. We could make a music generator. With PyTorch, yep, we sure could. Okay, so this should fail right here. This should fail. So now when I run this, it should be error, right? Boom. Yep, right there. Assertion error. E is A. Failure. Crash. Problem. Can we do a try except around that? I'm actually kind of curious about that. Try. I forgot how to do it in accept. I need an accept example. It certainly makes sounds, that's for sure. Yeah, we sure could. Yeah, we could. We could certainly make some sounds. What about Stephen Blum Music Generator? Making music using a MIDI keyboard. Oh, right. We could just make music right here with our own hands. You're sure right. Hey, Neva, good to see you. Hope you had a great weekend. Hope it was a good weekend for you. And everything's calm. DJ Blum. It could be, right? Disc jockey. That's what that is. How do we do accept again? I always forget to try accept in Python because I never. You probably should be using it. All right. Example here. Clear. Example. Try accept Python 3. I'm used to the Python 2 try accept. All right. Generic. Exception is E. All right. There we go. That's what it's about. Exception as E. As X. La la la. La 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 la. Yes, we need to make the music generator and give a thought to OpenAI and Suno. Oh, yes, a tough. Yeah, exactly. Give the tough to. Yeah, exactly. Dokul. We sure could. We sure could. The music makes me feel like we're in an RPG. It kind of is a little bit of RPG-ish, right? It's called Requiem in Cello. That's what this song is. So, that's a little bit right there. All right, print. Assert. Here, I'm just gonna do this. Asserted. We asserted. curious about this. We're messing around so we can learn. This is how you learn, you guys. You sure can put a try except around that. Look at that. Right there. Let's do an F string, and we will do EXC like that. So we can see what's inside that. What's inside of it? Nothing. There's nothing inside that. Print. Can I just print it out? EXC. I want to see what this is. Print it out. Dot message. Let me do that. There's no message. Hold on a second. Where is that? Where? Print error. That's what we're doing. We're doing that right there. Exactly. Why is it not printing anything? EXC. Yes. Whatever. I'm about to slay the code dragon real quick. Yeah, we could. All right, now we're in a little bit of a different genre of music. Wait, what is this song called? The Farmer in the Dell. Okay. We'll allow it. We'll allow it. It's Monday. It's fine. Okay. Where are we at now? All right. La la la. Okay. Perfect. Let's move on to the next thing. Torch ran print C out. Oh, so we can. Oh, it works for the creation 2. So C out 2. C has changed again. Still the same object. All right. Let's do this. We'll follow this example here. Okay. All right. Torch dot rand. You can make a new one. Out equals C. All right. And we can print this again. And it will be a different value of C. This time, the identity is identical as it always has been. Yep. 960, 960, 960, 960, 960! They're all 960s! And then at the bottom, though, we've got a different value this time, right here. Ooh, yeah. Okay. Neat. Straight up, if you didn't know this whole time, you can do something like this. I thought this was going to be really boring right here, but I was actually pretty excited about it. All right, let's do copying tensors, which is kind of, this is not the same thing as referring to the same tensor. So that's what we were doing. We were doing references. Now we're going to do copy by value. Let's do copy by value now. All right, we'll do copy by value. Let's quit this, MV tensory to copy by ref.py, and then we are going to do vim. This will be copy by value pi. There we go. Python. There we go. Thank you for the heart. Appreciate it. Good to have you guys here. A import torch. A equals torch dot. What do you want? Ones? Okay, ones. It doesn't really matter. Let's do a whole bunch of ones, one by one. All right, B equals A. Now this is not a copy by, this is a copy by value, not by value. This is a copy by reference. So B is now A. B is now exactly A. The music is killing the stream, bro. Yeah, it's. Wait, how long is this song? There's only 30 seconds left. Don't worry. There's only 30 seconds left. No worries about it. No worries. Hey, Kevin McAllister. Yeah. Okay. A01 equals 561. We can change A. B is also altered. Yes. So this is not a copying. This is not copy. Does not copy. Yeah, see, exactly. As with any object in Python, assigning a tensor to a variable name makes the variable a label of the tensor, and it does not copy it. We're gonna learn how to copy it now, you guys. That's what we're gonna do. This is a deep copy. Oh, we're gonna get into the deep copy now. Yep, exactly. Shinaz, exactly, Shinaz. We will. How many dimensions we actually create using a PyTorch? As many as you want. As many as you have memory for. You can make 100 dimensions. Do you want to do that? I don't know. Maybe as soon as we hit a certain number of dimensions is when consciousness appears. We're gonna find out though. We'll certainly find out. Increment. All right. Print a comma B. These are going to be the same. Python copy by value. All right. So these right now, just as contrast, these are copy by reference, and they're not really a copy. It's just a by reference. Do it. All right. We're gonna make it happen. It'll be a deep copy. Oh, do like a bunch of dimensions. You could. It's like this. Watch. If you want a whole bunch of dimensions, you go hi equals torch dot rand, and you go like 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, and just keep doing that, and as many dimensions as you want. Right? All right. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do 10. All right, 10 dimensions. And then if we try to print this, so there's 10 dimensions. We probably won't go higher than that because 10 is really high. That might crash. You probably can make 1 billion if they are all 1. Yeah, exactly. All right, let's drop that. All right, 0. Okay, here we go. Let's keep it clean. Let's keep it clean. Really easy. All right, here's 10, 1, 10. All right. Okay, there. Oh, all right, no problem. Right there. All right, so it's 1 value. Let's increment this by 1. All right. Let's make it a little bit more high dimension there. I think this should be fine. Okay, yeah. So you see a huge dimensions. Huge. You can go big. This is 10 dimensional. 10 by 10 is probably too much. Yeah, I'd probably say so. Hey, Neva, it's good to see you. Welcome on in. 2 by 10 is less than 1 kilobyte. So we could do a 2 by 10. We could definitely do a 2 by 10. Lots of dimensions there, you guys. A bunch of dimensions. Which is, if you want to do it, you can do it. You sure can. Would you want to? Is there a use case for it? I don't know. I don't know if there is or not. I don't know. Okay. Let's go back to the tutorial. So if you want, you can mutate A. Let's mutate A real quick. A. You can do this 0, 1. 0, 1. Like that. To set the value to like a big number. So it's like, let's set it to 4,000. So you can do that. Where'd that go? 4,000. Okay. Like that. There isn't really, although I have in the wild seen 5, and I think even 7 for actual real stuff. Okay, so 7. What is the dimensionality of string theory? Isn't it 11 or 12? So if we were going to be building a model for string theory, do we need like 11 or 12 dimensions? I think so, right? How many dimensions are in string theory? Batch time XYC. Oh, yeah, okay. Okay, yeah. That makes sense. That's like a real use case. So that's 5 dimensions right there. Absolutely. So we're usually dealing with, for me, we did 4 dimensions last week. 4 dimensions, because we've got color channels, XY coordinate, and a batch. So that's 4. And time, if you want to also add in a dimension of time series, right? Time series. If you were doing relativity for string theory, you can go up to 21 easily with just the math. 21? Wow. I was not expecting that. All right, let's see here. Clear. How many dimensions in string theory? All right. It'll understand my misspellings. Don't worry about that. 9 spatial, 1 time, 10, and 1. Okay. So it was about 11. In M theory, which is related, there are 11 dimensions. That's like the only thing I know about string theory. So we're done now. I'm like, gonna go any further on that. The only thing I was ever remembering, like, wow, that's a lot of dimensions. Why would you ever need that many? Apparently, if you have enough dimensions, you can make any math work. That's what it is. That's string theory. It's not special for that. You can make any math work if you have enough dimensions. Can someone tell me what is string theory? It's sort of the idea of a unification. It's like the only running candidate for a unification theory across micro and macro. Is that what that is? So the math behind large bodies and small bodies, like atoms and really tiny things, right? Really tiny things, neutrons, neutrinos, and bodies like the sun like large giant objects with gravity. Isn't it? It's like the only unification theory candidate. Right? And then if you want to go in further, you can find out why. And then you can look at like a whole bunch of math and be like, what's going on here? I don't know what this is. For context, 2 to the 21 times 2, assuming you're using an F16, you got up to a gigabyte. So, and that's just with 2 in each. Oh, got it. With 2. With 2 in each. That's a lot. That is a lot. That is a lot. We'll struggle. We'll struggle with that. Even a computer will struggle with that. It becomes absolutely ridiculous. It sure does. Okay. So we can overwrite that value, which we just did here, and we can verify that B is still the same. So we do that. Print AB. AB should be identical. Should be identical. Yep. Ones looks good. Ones. Yep. Okay. Tensor 1 4 1 1 1 4 1 1. They're the same. Yep. You got it right there. Anything over 10 is unrealistic unless they are degenerate. Well, yeah, got it. So we get into theory zone at that point. Unrealistic. I'm actually kind of curious. How many dimensions would we need to measure reality? How many do we need? 4? 4 at the low end, right? 4 is the minimum? Okay. So, but what if you were to... Okay, what if you were to separate a copy of the data to work on? Clone, here we go. Now we're gonna copy by value. That only took 10 minutes. I meant unrealistic run in PyTorch. Oh, got it. Yes, okay. Yes, unrealistic run on a computer, like your computer would crash. Yeah, it sure would. It would eat up all the memory. It would try, and then it would out of memory error. It'd go, out of memory error. Crash. Yeah. Explosions. Okay, here we go. Let's do a clone. There's a dot clone method right there, you guys. A dot clone method. All right, so let's do b dot equals a dot clone. One second. Oh. Okay. Music. I'm changing because I don't know. Here we go. Okay. Like for context, 32 to the 10 is more than any GPU out there ever had. Yeah, all right, yeah. 22 to the 40. Ooh, now we're into the zone of no computers in the world. If you combine all the computers in the world, there's not enough. There's not enough. So we could do A and B. So these they're cloned, but B is going to be different, right? So you can print B. Assert A is not B. All right, right. Torch the EQs, but still with the same content. Yes, exactly, because we cloned it. All right, torch that EQ. That's pretty neat. I'm actually kind of curious about this one. Print torch dot EQ, A comma B. Let's check what that looks like. True. Can we do the same thing with the equals equations? I think so, right? I think that's the same. Yeah, okay. We're looking good there. You sent a video of something cool in general real quick? All right, real quick.
Here's my physical computer, and here's a pop-up above my physical keyboard. If I move the keyboard, well, this is supposed to move, but it's not doing it. And if I press connect, then I'm going to immediately go into immersive again. And voila, you have my desktop just right here. I can, this menu, go away for a second. I've set it to wide. You can do anything I would normally. Let's just clear the recycle bin. It's a bit laggy because, well, this corner of my room has pretty bad internet. But,
wait.
And the cooler part about this is I can also change to ultra wide.
Whoa.
This is kind of ridiculous. Actually, just bumped it up to 1440p, I think, as well. Not sure why I did that, but yeah, this is ridiculous. You could fit so much information on this.
Your spreadsheet could be massive. You could have a giant spreadsheet.
just for funsies. Let's open up Arduino IDE. Just for like funsies.
You would have just if you scaled the window large. Look how small it is.
This is how it normally looks. Actually, it might be the script I actually need to submit. This is how it normally looks. And now, let's see if I can actually maximize it like this.
Yeah. You just a bunch of white space.
It's ridiculous, but it's like really cool.
That's crazy. Jin Lu, that's a very neat that you could do that. You just the biggest Excel spreadsheet ever. Exactly. Giant Excel spreadsheet. We go forever. I could actually use that in many cases because we have spreadsheets that go on for a long time, and I have to scroll a lot. Very cool. Can we restart the 80s fantasy movie soundtrack? Oh yeah. We're in the future, you guys. That's really exciting. That's really neat to see. Someone need to make an Excel spreadsheet that holds all the names in the world. You know what? I bet someone has done that already. Or gotten pretty close to it. There's a lot of names out there. There's like, what, 8 billion people? How many names, how many unique names can there be? I'm actually kind of curious. It's got to be less than a billion by far, right? Unique names. You think it would be only 1 million? How many unique names are there in the world? Actually, I wonder, how many unique names in the world? That's probably, this is probably, someone else probably. Only 29 million unique names, and there's 8 billion people. That's crazy. That means you'll very likely run into people with the same name as you. All right, let's get back to PyTorch, you guys. Okay, PyTorch, A equals, okay. So we did that here. We updated this here. And then we compared the two. However, this time, if you mutate A, it's going to be different. If you remutate A, it's going to be different. So, and then we try to reprint B. So if we run this, here, let's do this. We'll just do a whole bunch of numbers like that. So it's really obvious. MetaQuest 3 is only $500. Oh, nice. You can do this on a Mac as well. Very nice. Yeah, the thing is, I don't want anything. It's neat that you got that. For me, I don't want anything on my person. Except for like maybe some clothes, and that's it. I don't like anything else. It's got to be nothing. Bet numbers, mostly of them are by crazy parents. Oh, you bet by numbers. Yes, exactly. Yeah, exactly, Neva. The names, the shared names, so many shared names. Make a name generator, adjective plus animal. Then you can create any name. You would have unlimited names. Infinite names. Well, nearly infinite. I guess actually it's not going to be infinite because we have a finite number of words. In combinations of words. So, you can only have so many names. Fair enough. Yeah. What you've got is really neat though. It's really neat. Invent new words. Oh, there you go. Infinite words now. There you go. Now you've got infinite words. Do you ever do embedded software engineering? Yes, I've done this before. I did. Many years ago. Arduino, ESP32, PIC32, MPSs, a whole bunch of different things. Really, it's the microprocessor, and usually it's cooperative tasking, so it's just a cooperative operating system, which means that whatever is currently using CPU gets the CPU, so it doesn't have like multi-processing capabilities. So yeah, absolutely. Okay. All right, let's bump over here. Print B is going to be B different. Let's find out. This is what I want to see. I want to see this. I want to see this. Random German word plus maybe some adjective. Yeah, exactly. Stark, Freen, Fern. You come up with a whole bunch of names. All right, so what did I want to see? I wanted to see that A and B are different. Okay, so 1, 2, 3. Yeah, here's 1, 2, 3, 4 right here. And B is still stuck on 4 because we cloned it by value. All right, we're learning new things. The duck clone method, right there, the dot clone method. Easy, easy. You've been working to port Linux 11 to an ESP32 C6. Can you do that? You can, you know what? You probably could. So that Bonzupi? Why are you doing that? I'm actually kind of curious. Steven, can you one stream do something with FPGAs? Oh, that would be a lot of fun. Yeah, maybe, is there an FPGA emulator that we could use, or do we need actual hardware? Thank you for the hearts. Hey, Mark Lemon, good to see you. Thank you for saying hi. Welcome on in. Just because your friend Larry said I couldn't run Linux on it, so you're gonna prove Larry wrong. Hey, look, Linux is running on it now. See right here, proof. You proved it to Larry. A basic lexicon with 460 animals and 2,100 adjectives produces almost 1 million combinations. That is quite a bit. Cunning, silent, flaming. Okay. Octopus, basilisk, buffalo. Kyle, we're coming with a whole bunch of names now. You can come up with quite a few. There is a Python thing that lets you program FPGAs and simulate them. Oh, really? That actually is kind of nice. All right. Let's find out. All right. Clear. Okay. What Python libs for FPGA emulation? Okay. Let's see if we got any here. Run a quick little search here for this. I'm treating this as a tooling recommendation question. Okay. It's doing web search now. All right. We'll leave it be for now. We'll come back to it in a moment. All right. Thank you for the hearts, you guys. Cathix, hey, how's it going? This is what YouTube live streams for. It sure is. Exactly. This is what what else do you want YouTube to be? This exactly. Becoming software engineering conversations of topic. You made a card game and studied the name thing. Oh, that's why. Oh, Kyle, got it. Okay. That's where that knowledge comes from. Got it. Understood. All right, let's see. 000. Zoom in a smidge more. There we go. Make that easier to read here. Yes, much easier to read now. Okay. There's an important thing to be aware of when using clone. If your source tensor has autograd enabled, then that will also be cloned. This will be covered more deeply in the video auto. Okay, so we're not watching the videos, we're just reading. If you want a light version of the details, continue on. In many cases, this is what you want. For example, your model has multiple computation paths in its forward method, and both of the original tensors clone. Let's see here, clone to the model's output. Then to enable model learning, you want autograd turned on for both tensors. If your source tensor has autograd enabled, which it generally will if it's set to learning weights or derived from computational involving the weights, then you'll get the result you want. Really? I don't know. What's the result I want? I don't even know. Well, I don't even know what I want for my result. If you're doing computation where neither the original tensors or it's cloned need to track gradients, then as long as the source tensor has autograd turned off, you're good to go. Okay. Making a card game is a really great project. It teaches you so much. Probably a lot of game theory, a lot of strategy, how players are going to be involved, user interaction, progression, right? You need a story arc, maybe. There's probably a lot of stuff in there. I'm just saying words right now. I'm just saying words. I've never done this before. There's a third case, though. Oh, uh-oh. Hold on, guys. So wait, there's a third case. I was not expecting that. My Linux kernel is 42 kilobytes and runs on 128 kilobytes of RAM. I've been having a lot of trouble getting it to boot into a shell, though. Oh, Bonzupi. Well, as soon as you get it to the shell, I count that as a victory. Wouldn't you? No, you're right. Oh, I might. All right. Just making up words. Making things happen. All right, you guys, here's a third case. We've got a plot twist here. I didn't know about this. There's a third case that's coming around the corner. It's going to surprise us. All right. Imagine you're performing a computation in your model's forward function where gradients are turned on for everything by default. However, if you want to pull some values midstream to generate some metrics, that kind of ended early. In this case, you don't want the cloned copy of your source tensor to track gradients. Performance is improved with autograd's history tracking turned off. For this, you can use the detach method on the source tensor. Okay. Detach.clone. You detach before you clone. Got it. Okay. Detach before you clone. Okay. La 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 la. R equals a dot detach dot clone. Like that. And R. All right. Some nice little bits of knowledge for us. All right. The Linux kernel does technically run on the ESP32C6. So I call that victory. Oh, you're already victorious. Okay. Can you use it for anything? No. I mean, that's like the next question that's coming up, right? Is there any practical use case for this, right? Or the answer is yes, there is, as long as you can actually show that it runs something. It is a good point, though, Bonzupi. You did technically succeed. In every sense of the term, you succeeded. Now the question becomes, why? Why would you do it? Why? That would be like the next phase to get to the next level. All right. All right, la la la. What's happening here? We clone A, label B. Yeah, we already walked through this. We walked through all this, right? The detach method detaches the tensors from the computation history. Yeah, so we don't have it on a graph anymore or anything like that. Does what next with the autograph is off. It does this without changing A, so you can, then we print A again at the end, and it retains the grad true property. Moving to Accelerator. All right, so we know this one. This is one of my favorite things that you can do in PyTorch. But like the whole reason why PyTorch and NumPy are pretty significantly different. Because there's this one thing right here where you can move it to Accelerator, and all that same computation that you've already written is still the same no matter where you're running it from. Are you running it on an accelerator or on a CPU? The same code, both ways. It's great. PyTorch card game, maybe? You know what? We probably could. Let's think about how that would work. How would that even work? If we were going to build a PyTorch game that is a card game, what would be some of the bonus benefits of doing that? Would it be generative AI that can generate new cards randomly, so you never know what you're dealing with, and it'll be more difficult to strategize? PyTorch, $2 from Kyle. Thank you for the super chat. I was not expecting that. Appreciate it. Thank you, Kyle. Let me say at Flip with Kyle. Thank you. Explanation point. Kyle, you're number one. You're number one. There's no one else but you. You're the one that donates the most. Seriously, you are. I've had other donations before and other people, but Kyle, you win. You're number one by far. Thank you, Kyle. Appreciate it. My gratitudes. Oh, what are you doing? It's only Monday. PyTorch card game would be a lot of fun though, right? Wouldn't it? You need to make this flip profit demo and segment the tech from the app. Oh, you need, you need to make this flip profit demo and segment the tech from the, oh, got it. Okay, got it. Maybe 305 minutes? 3 to 5 minutes. Got it. Yeah. A good description walkthrough demo is important. It needs to be done quickly and easily so everyone understands what's going on. Very quick, very fast, very short. You got to bring them to the aha moment as soon as possible. While you're in the aha moment discovery phase and you're trying to teach whoever it is your target audience is, you have to surprise and delight them. Otherwise, they get lost along the way. You gotta be woo, woo, woo. You flash the pretty pictures like, ooh, hey, that's interesting. And then they trail off after 30 seconds. And so you need to do another surprise and delight pretty quickly afterwards. You're taking notes? Nice. You posted a screenshot of it booted. Oh, in the super basic shell and counting clock cycles, Bonzupi. Oh, there you go. All right, you did it. You did it, Bonzupi. Look right there. Minix roots mounted from Flash. Clock cycles. You did it. Jiffies. Wait, is Jiffies a common thing? No, it's not. I don't know. I don't know what Jiffies is. Oh, this is cool. It is. It's really cool. Very nice. Look at that right there. ESP32. Linux 11 right there. You proved it. You did it. Good job. Very nice. When I say segment the tech from the app, I mean explain your vision from the user segment. Also explain the tech for different verticals. Got it. Yes. Yeah, the tech is how you did it. Separating the tech will allow you to explain why it's important. It's all about the why. Remember, if it runs instructions, it can probably run Linux. Good point. That's what it is, ESP32C6. It's running instructions, it could run Linux. You proved it. All right, let's get an accelerator, you guys. Let's get an accelerator going. La la la. So if torch accelerator available. All right, let's do this. All right, close that. By accelerator, accelerator.py. Torch. All right. If torch.accelerator is, wait, accelerate, oh wait, torch.accelerator, okay. Torch.accelerator dot is available, underscore available. Then we'll say something. All about the why. Yep, you got it. It's all about the why. You got to explain the reasoning behind the product, why it's necessary, why it helps. It's kind of, so what I like to do is I like to create a little mini version of a white paper. The white paper is a really simple format. You explain the current world, why the current world is broken, or what's wrong with it. You explain what the new version of the world is. So it's like, sort of take that 3 steps. Like those, there's a few more steps in there, but those are the most important. The current world, like today, what we do is we have to slowly and meticulously inventory all of our items that we're going to be selling in the store. It is a tough job to do that. And we have to label and mark and inventory everything for customers who come into the store. Wouldn't it be great if we had a new magical XYZ thing? It sure would be, and in fact, now we do. White paper approach. The laws of computers say that anything that has a way of processing data and displaying images can run Doom. You know, that is the law of computers. It sure is. It can run Doom. I have done a lot of white papers. I'm aware of them from the past work. Nice. Wait, but there's more. Exactly. Wait, but there's more. Is available. Available. Right? Did we do that right? Print. We have power. Right? We're powerful. Else, we do print. Sad. All right. Only CPU. Okay. Do we have power, you guys? Do we have power? More, you say? How much more? Cookie Monster? Exactly. How much more do we? All right, we're going to tell you how much more and why it makes your life so much better. That is the way to sell. You got to sell. Surprise and delight. You don't think my chip could run Doom, though? Oh, it couldn't? Are you sure, though? Maybe it could. Maybe if you made it run a little bit, you could. Maybe could it print 1 frame of Doom, maybe? Just a single frame? All right, let's find out if our accelerator, Python accelerator, is going to, yeah, we have power right there. We sure do. We have an accelerator. All right, so now that we know that we have an accelerator, what can we do with it? We have an accelerator. It's available. Accelerator, that current accelerator. All right. This is my favorite method right here in PyTorch. Before, you had to do a little bit of jumping around. However, you don't, there's one built in right there. ESP32 can run Doom, I think. It feels like it might be able to. It feels like it could. All right. Where are we on time? We're good on time. Okay. So we have power. We're good to go. Let's do fire emoji, so we know better. All right, I'm gonna flame, fire, right there. We have power. All right, so we're gonna say print torch.accelerator.current. Is it a current accelerator? Yeah, it's one giant long word. Accelerator, right there. Actually, wait. Device equals. Let's grab that into a variable here. Device. All right. We'll say fstring equals, say, our accelerator is, We'll put this in single quotes, just to highlight a smidge more. You need a logo on a shirt. Trim my beard and put on glasses. Founder swag. Oh, right, yeah, you gotta become the CEO. You have good glasses, and then you gotta look like fancy, right? You gotta quaff. No, quaff. Quaff, there you go. Right? Get all fancy looking. Big, giant, like, sweatshirt or big, giant, like, turtleneck of some sort. Okay. All right, here's our device. It's gonna be MPS. That's our accelerator right there. Isn't that great? It's really nice because the whole point of PyTorch really is to help make things easier when you're writing your model to run on different architectures. It's automatically abstracted away from you by PyTorch. Power, exactly. We've got power right there. Sergio, you got it. Montana. I could look at it like I'm pressed for time throughout the video. You could, exactly. You're like, this video, we got to get through it real quick. We got to power through the video. All right, and you can be like very serious. Have some serious. So one of my things is I really enjoyed like satire, things along those lines. Not taking things too seriously. I think it's a lot more fun. But that's what you're doing, Kyle, exactly. You're acting like that, and it will come across that way in a good way. Let me take a picture, all right? 10X Studio, how's it going there? Hey, Steven, very early stream. Yes, there's a meeting early. You got it. So the rest of this week and next week, we have very early meetings throughout the day that I don't have time to stream for. So we're going to be doing early streams for the next week. And next 2 weeks, actually. You got it. Early streams for the next 2 weeks. All right, finish making your food. All right, Jen Lu, sounds good. Take a picture. Oh, you can take a picture, yeah. Have never moved a model across architectures without some level of code change. Really? Really? I mean, you've done CPU and MPS, or CPU and NVIDIA probably. That probably works perfectly fine, right? That counts. Although between NVIDIA and MPS, maybe there's a difference there? I'm not sure. It's not supposed to be. Sent general, all right. Hey man, I'm late also. Hey, how's it going there, Claude? This is an early stream. Yes, we're gonna be doing early streams for the next 2 weeks. Let's look at dinner. I'm actually hungry. Oh, that looks really good. All right, a bunch of vegetables. We got some sausage of sorts. Looks like a tomato base, cottage cheese, and potato. Did Claude get mod? Claude got mod at some point. Yeah, it happened. The XPU. Oh, Intel. Yeah, okay. Yeah, XPU. Okay. Yeah, that one counts, Neva. That one counts. Let me get some new product launch. Yep. you figured it out. Yeah, exactly. The whole thing of not needing to specifically different device names, it like super duper new. Oh, is it? It's pretty new? This looks really good. I'm hungry. I want to eat now. I want to eat. I like how you've got a whole bunch of like wires right next to your food. And some PCBs. It looks like some scissors. It's like right there. The sauces are actually some word, but basically the same thing. Okay, sounds good. That sounds really good. Bread connectors. Oh, the bread connectors. Oh yeah, and the breadboard. Okay, yeah. The board that has just a whole bunch of holes in it. On your desk is a mess. Yeah, you gotta get your desk clean. It's even worse with Gaudi because the memory model is less coherent. You need some sync statements added. Oh, really, Neva? I've never used that before. Is it your food right now? Yep. Jinlu made some really good dinner right there. Also, if you have more than one GPU, same thing. Oh, more than one GPU? Yeah, that makes sense. Then you need to prefix or postfix. Yeah. So here. So you do :0, :1, :2, :3. So you can have you can put it on different devices. Those PCBs are disassembled Bluetooth headphones, are they? Are you for real? Yeah. How's it going there? Coz XY? Cozy? Is your name Cozy? Good to have you here. Yes, real enough. Yes, hello. Hey, Savon, good to see ya. Hope you had a good sleeping weekend. I found you again. You sure did. You found me again. All right, let's get back to this is Jinlu's dinner. It looks really good. I'm actually really hungry now. You've got a very healthy dinner there. It looks like very healthy. You need to rewrite the model so it fits on more than one GPU, or split the data across GPUs for both. Yes. How would you do that? That would be the way to do it. Okay, accelerator. By default, new tensors created on the CPU. So we have to specify when we want to create tensors on the accelerator with the device. Optional device argument. You can see we print the new tensor. PyTorch informs us which device it's on if it's not on the CPU. Hey Anasazi, welcome on in. Good to see you. Happy Monday. We're continuing our PyTorch expertise journey. Join me together. Let's do this. Only one missile attack. Okay, this morning, so some sleep was obtained. Nice, you got some obtained sleep there. Good to hear it. The numbers are related on our specific GPU count and the VRAM size. Yeah, it would be. It's very early over there, isn't it? Yes, it is. So we're waking up early so we can stream, and we have meetings that are packed for the next 2 weeks. So we have to only stream in the morning. Yep, exactly right there. Ooh, device count. Let's do device count. I've never done that before. Let's do device count. All right. Print torch torch dot accelerator dot device underscore count. Can we do that? Like that? Is that how we do that? Normal people, terminal is just programmers user equals wow. Oh, wait, what are you saying over there, Clyde? Now I got power in the terminal. Oh, yeah, exactly. We have power. You see what we have there? Yeah, because we've got an accelerator is what that is. That's what that is. Nice, yeah. Schedule is more packed than Amazon's packages. Yeah, it is. I'd show you. It would give things away though if I did. I'd show you. All right, you guys, can we do that? Is that what we want to do? Device count, accelerator dot device count. Okay. How many accelerators do we have? Print number of I think it's just one accelerator. Accel How many we got? One. Yeah, it's just one. We got one accelerator. Don't worry, it's an okay accelerator. We're perfectly fine. We've got plenty of acceleration here. Current accelerator if torch is available. Wait, else CPU. All right. So my device equals current accelerator. Oh, this is a nice one line. Okay, I like this. This is pretty good. This is like the one line that you want to use in every one of your projects, essentially, for the most part. Is one of your schedule entries bullying Jarvis? Jinlu. A little, kind of. It's not really bullying. It's more like collaboration. It's a little bit more on the collaboration side. Jinlu's humor is nice in a positive way. It is. Agreed. Nice in a positive way. All right, so let's do this. All right, so my underscore device equals torch.accelerator dot current accelerator if torch dot accelerator dot is available. Okay, is available, and then we say else CPU just like that, right? I think that's it. Oh, isn't it the same thing? No, you could do the same thing. You could say CPU or these are identical. I didn't know you could do this. These check this out. Okay. So wait, let's print my device first. Print my device. And then I should see MPS. Yep, we got MPS. However, check this out. All right, CPU equals torch.device CPU, right? I think so. Print? Maybe. Expensive isn't always the right solution. Building. Oh, got it. Building. Sorry. No worries. All right. Same difference. Same difference. All right. Is it gonna be true or false? It is false. Okay. So wait. Hold on. So what is this? Print. Is there a string method there? It's just gonna say CPU. See, right there. It's CPU. Hold on. Is there like a string function or something maybe? Right? So we're gonna have two CPUs printed on the screen, right? Right? CPU, CPU, right there. CPU, CPU. They're the same. They're the same, right? CPU, right there. Why is this not true? I think the CPU out of the print dunder. It is in the print dunder, isn't it? Yeah, it's in the print dunder. That's what's going on. That's what's going on. However, I believe you can also just use a string variant when you're doing a .2. So this is what I was thinking. Torch dot, let's see, rand. We'll say 2,2. Can you do that? And then you say device equals MPS. I think you can do that. Say print this. I'm pretty sure you could do that. I think this will work right here. All right. La, 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 la. Yep. See right there. You could use a string version of it. So these right here, that works as well. That also works. You can do the same thing as well here. You can say device equals my device. My device. So that right there should be identical. It should be identical. Let's see here. La 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 la. On the device side, yeah. So you can see right here. Yeah, device is the same on either side. So you can either just say a string if you want, or you can use whatever that is. Whatever that thing is. Let's see. I'm gonna say this Python. Let's do this real quick. Import torch. Do we already import it? No, we didn't yet. Okay. All right. Torch.rand 1, device.
Yeah.
MPS. We can do that? Yes, okay. So we can do that. That sounds good to me. Okay. Then what was I thinking here? What else can we do here? What was I think? I was trying to make a point. I was trying to like dig something up here. What was I trying to do? Device, torch, rand, device, CPU. I forgot. Oh well, we'll move on to the next segment. Have a wonderful day. All right, guys. All right, Sergio, enjoyed the stream as always. Thank you. It was good to see you. Happy to have you here. We'll be back tomorrow as well. More PyTorch, you guys. You're pretty sure Google took away the clipping? Oh, did they? They probably working on it, I guess. Oh, for videos. Got it. The clips in the YouTube. So YouTube clipping. Understood. Got it. I didn't know if there's any special settings to use on that. There might be some special settings. Okay. Anyway, we got 30 minutes left, you guys. Let's keep on going. Still have the clip option, so it might be just some A/B testing. Oh, okay, got it. Yeah, it could be some A/B testing. Have you seen YouTube's AI video app? I've not seen the AI video app yet. I'm curious about it though. Are they trying to compete with OpenAI? What's it called? Sora on the App Store? So we can do divide. Oh, right here. Oh, right. Okay. I wanted to see what this is. So let's try this. I want to see this. This is what I wanted to do. MPS. Okay. It just says MPS. That's all it does. YouTube Create. Oh, it's called YouTube Create. Okay. You have to enable permissions to use users to clip from the live stream dashboard of YouTube. Yeah, I thought I did. I didn't disable it or anything, so it's not any different. YouTube Create is the name of the app. All right. YouTube Create app. This looks like an editor. Automatically adds captions. Edit with AI to quickly trim and edit videos. Ooh. Here we go. Auto editor right there. Generate videos with AI. Oh, there we go. Generate videos with AI right there. YouTube Create. That's what you're talking about, Kyle. Thousands of royalty-free songs. I want more royalty-free songs available to me so I can stream them. Sync your video to the music. Ooh, nice. Unique filters. All right. Now I should be using YouTube Create app, apparently. You have Sora open source weights. Oh, Sora is good. You have Sora open source weights? How'd you get those? Wait, really? Anasazi. Are those available to everyone, or did you get them special? You know YouTube Create from its beta started. Oh, you know the YouTube Creator from its beta started? I'm following from started beta first time now. It's editor for YouTube ecosystem. Claude, here, make words sound easier. I don't know what you mean. How did you do the voice response feature? What's the voice response feature? What do you mean? Do the graphic designers at YouTube don't know how to properly contrast colored text with the gray background? Oh, yeah, what? Yeah. I don't know what to say about that. I mean, yeah, I can't disagree. You can get them 23 GBS. That's all it is. In the YouTube comments. How do you get the voice? Oh, yeah, you just go on the mobile app and then you click the voice button. That's what it is. Got it. Yeah, that's it. That's all that was. There's like literally a voice record button and you can respond to voices right there. It's like a little weird icon. Here, I'll show you real quick. Actually, here, I'll show you. So you group up over here and you look at a comment and then you look to respond. You can see, I don't know, on the screen there, I don't know if it shows up. There is a little button right here next to the text input area. You click that button. Let's see, just click it here. Did it work? No. You click that button and it brings up a voice record, and then you just click on the voice record button right there. Boop. And it starts recording. That's how that works. It starts recording. You're looking to hire, currently looking for a job. Yes, we do have jobs opening. We are on our careers page on pubnub.com. You got it. It sure is. Oh, you got it. And then you click the send button and then it loads and it uploads and boom, there you go. Easy, easy, easy. Just like that. Oh, button replaces the camera button, I guess. Yeah, it does. No one uses that. Still waiting for when I can put images on the comments. Oh yeah, you could. Someday maybe. All right, let's get back to our source code here. Can get them from Hugging Face. Oh, I can't find them. Okay, got it. So you got them from Hugging Face. Okay. Have them on mine. You can get them there. Okay, nice. All right, good to know. You mean following YouTube Creator from start, beta stage to now? It is. Okay, so you started watching them early. Got it. You started watching them when they started. All right, where are we at here? Let's get back to our code. We have 25 minutes. We've got time. All right. There's a .2 method. We already know about the .2 method. We don't need to repeat that one. You can also initialize directly like this, right? So did we do that? Yeah, we did that already. Hey, we already did it. We're ahead. We're jumping ahead in the tutorial. Sometimes you'll need to change the shape of your tensor. Below, we'll look at a few common cases and how to handle them. All right, you guys. So let's get into tensor shaping. Close that. By tensor shaping. Let me do reshape.py. Okay. So let's reshape. I think we're gonna use the .view method. We'll probably be using the .view method to reshape it, right? Is there gonna be a .reshape? I don't know. Let's find out. All right, so we say a equals torch.rand. Do a simple torch there. A.view is going to be a method. What about reshape? Shape is definitely a method. Is reshape a method though? It is. Reshape is a method. So what's the difference between view and reshape? That's my question. All right. Changing the number of dimensions. All right, there's in case you might want to need to change the number of dimensions, passing a single instance of your input model. Yeah. So if you got a batch, for example, model generally expect batches right there, right? We know it's got reshape is good. Reshape versus view. I'm actually curious, like, so reshape versus view. Versus view. I'm curious about the difference. We're gonna find out. There's also unsqueeze, which you taught us that one, Neva. and I don't usually know when to use it. Imagine we have a model that works on a 3x200, a 3-channel, so red, green, blue, and a 226 image. So a square, 3 color channels, yeah. When you load and transform it, you'll get a tensor shape of 3 and then 226. Your model, though, is expecting input shape of n, which is batches, 3, 226, where n is the number of images in the batch. So, do you make a batch of 1? So, how do you make a batch of 1? Okay. So that's what that's about. Reshape may sometimes clone for tensors that are not continuous. So reshape is going to do a little bit more work. Got it. Review, it will never clone. Is that right? Is that how you say that? So this is neat. So unsqueeze is not going to, it's going to inflate it. It's going to add a dimension. That's what that's going to do. Have you guys ever needed to unsqueeze something before? Well, it turns out, no, you don't usually need to. That's not the answer. Though unsqueeze is pretty great because it's going to turn a tensor of the shape like this into a tensor that's a shape like that, which is going to give you a batch size of 1. A really nice, quick way to do that is unsqueeze. You think reshape call views? Oh, so it's like basically the same. I was wondering about that. I really was. I'm like, are they the same? Are they synonym? Are they synonym? The unsqueeze method adds dimensions of the extent 1. I mean, does it? What if you unsqueeze it differently? Let's mess around with this, you guys. Let's unsqueeze this. All right, a dot unsqueeze. Like that. Oh, it needs a dimension. Wait. Let's go 2, 2. One moment, you guys. Just 1 second. Okay. Also, beta tester of the first started beta tester batch of ChatGPT from 2022. Guessing you are also right? Yeah, yep. I remember that. It could generate words back then. It could generate words. I remember that. Unsqueeze. Okay. Unsqueeze. Unskew EEZE 0. It's going to add a dimension, right? So that adds a dimension. It basically adds another bracket. And if you just unsqueeze this a whole bunch, watch this. So you can do a whole bunch of unsqueezes. And it just keeps adding more brackets. Right? As many brackets as you want. Just keep unsqueezing. Brackets everywhere. Brackets all day long. Can you just squeeze? To bring it back down? Oh, look at that! It brought it all the way back down! That's pretty neat. I didn't know you could do that. That is pretty neat. What, can we put a number in there? Or is that, it can't be a float. Okay, that's fine. Look at that. Unsqueeze 4. What about 44? Too many unsqueezes. Okay, 10. All right, 14. 19. All right, I don't know what that number is, but if you unsqueeze it, it's all the way there. It's all the way there. AI maxing. Oh yeah, AI maxing all the way to the max. This is your ChatGPT comment. We'll be laughing humor because Claude says I'm ChatGPT beta user, but you know I'm human. As far as I can tell, you're human because there's several indications that you're human. We got several indications there. All right. What if we unsqueeze it differently though? Here's what I want to know. Can we unsqueeze it differently? So what if we unsqueeze on 1? How does that do it? Where does unsqueeze 1 versus 0? What's the difference? I can't tell. Oh, okay. So it adds an extra dimension interior. So I should be able to go to 2 and it should be all in brackets. Yeah. Okay. There we go. Okay. It adds a dimension, and you can say at which dimension to add it. Understood. So unsqueeze, you can add a dimension exterior, or you can add dimension interior as you go up. All right, this is really good to know. This is really good to know. We might need this later on. The ChatGPT, let's see, users in beta while Claude users are alpha. Okay, yeah, you sure could. Or you could do it that way, right? You're saying beta user as in alpha versus beta versus omega. Is omega, so I've heard of alpha user, right? Alpha testing is like before it's even ready. Beta is it's kind of ready and you want to test it for the market, but you know there's things that need to be finished. What is omega? Okay. So we're messing around with the unsqueeze. Let's look at the shape though. Let's look at the shape. I think that's going to be a little bit easier to see. It's not a function. It is an attribute. All right, so unsqueeze 1 and unsqueeze 0. Oops, darn it. All right, we'll have to redo that. 0, so 0, 1, and 2. There you go, okay. So you can see here where the dimension is being applied. So you've got the first dimension, the second dimension, and the third dimension. Easy stuff right there, you guys, easy stuff. Using ChatGPT, think you remember, it's January 2023, just after ChatGPT launch. Thank you for the hearts, you guys. Good to have you here. Dear darling, hey, happy to see you here. Super Steven. Dear darling, thank you for hanging out with us today on Monday. We're becoming PyTorch experts. We're messing around with all the functions until we memorize it really, really well. And then we're going to be building some pretty neat projects. We will. We'll be building some really neat stuff on this channel. Thank you for the hearts, you guys. Appreciate the party poppers, too. Appreciate the party poppers and hearts. All right, where are we at here on our tutorial? Where are we at, you guys? All right, so we did mess with this. We're looking good on that. We got the unsqueeze good. Yeah, you can do that. A whole bunch of numbers right there. And then you could do squeeze to bring it all the way back down to 1. Right? Did we jump ahead? I'm just wondering if we did or not. Let's see. Yep, there it is. Right there. I knew it. We did jump ahead. Oh, I knew it. Okay. Brings it all the way back down. So we just jumped ahead in the tutorial. That shape to shape. Isn't that neat? Hold on. Let's try this real quick. I want to see what this looks like. There's a really big one in here. Here we go. Dot shape. Shape. There we go. There you go. All right. So a very high dimensionality right there. Very high dimensionality. Unnecessary amount of dimensions. You want a few dimensions there? There you go. All right, you guys, we got 15 minutes left. Let me see here. Where are we at here on my calendar? Let's see. I want to make sure we're on the right track here. All right, what is this? Okay. Good to go, you guys. Let's keep on going. Let's make our way to the next phase. You can see from the shapes our two-dimensional tensor is now a one-dimensional. If you look closely at the outputs of the cell above, you'll see that printing A shows an extra set of square brackets. Yes, we sure saw that, didn't we? We saw a whole bunch of extra brackets. You may only squeeze the dimensions to extent of 1. That's what we found out. We found that out, yeah. You know, you can go live together here on YouTube. You can do a dual. There's like a dual mode. You can like dual stream, like 2 streams together. Wow, really? No way. I didn't know you could do that. I thought that was only like a third-party thing. I didn't know that you could do that. That's pretty amazing. Hey, Fizzy, good to see you. Happy Monday. Welcome on in. We're becoming PyTorch experts, you guys. Let's learn together PyTorch and every single aspect. All right, where are we at here? Ones, torch up. Oh, yeah. Third dimension 1, second dimension identical. Yes, okay. Understood. The feature is called Go Live Together. Oh, that's like a pretty well-named feature, isn't it? Go Live Together. There's an easy button there. The net effect is the broadcast operator over the dimensions of 0 and 2, causing random 3x1 tensor to be multiplied element-wise by every third element column in A. If you got confused there, that's perfectly fine because it doesn't really matter. It doesn't matter that you understand that. So it's basically, we've got a two-dimensional array of a batch of 4, and as long as we share the same dimensions of 1 or a 2, You can't go any higher than that though. You can do a broadcast. We learned this on Friday last week. A equals torch dot ones. Come on. Let's do, wait. 4, 3, 2. We'll go B equals torch dot ones. Let's do rand. No, what? Let's do ones and we'll just add them together. We'll say 3, 1. Right? Then you can go. Oh wait, I thought I was in Vim. I keep doing that. Sometimes I think I'm in Vim. No one uses it though. Oh, they don't? I didn't even know about it. How do you do that? Like, I don't see any buttons. I see no buttons for it. I'm sending you a live join request. You should see it in your dashboard soon. JK, do it. I want to try it out. Oh, wow. All right. Okay. I don't know. All right. Sounds good. All right. So A plus B should work perfectly fine as long as you say the right number. Yep. What can you do? A times B. You should be able to do A times B as well. But it'll be the same values because 1 times 1 is 1. All right. The net effect of the broadcast. Blah blah blah. Okay. Understood. Oh well. Okay. So where are we at here? You could join him through Discord call on the, yeah, exactly, right? So through third party Fizzy, you got it, exactly. How to join, click the invitation link sent by the host on the mobile device and then select the channel you want to join in the waiting room. Python, yes. Hey, how's it going there? Gushin? Gushin, good to see you. Welcome on in. Python. That's the only word I understood there. Python. Yeah, TikTok does have this. I've seen it. I've used it before on TikTok. Squeeze and unsqueeze, squeeze and unsqueeze. Yep. So you can mutate. Allows you to mutate. All right, I'm fine with that. Where are we? Are we nearing the end here? Okay. So where are we now? Oh, reshape. Okay, now we're in the reshape section. All right, let's try this. Let's do the reshape. Okay. So this is the reshape tutorial that we wanted to get into. Here we go. All right. A equals torch dot rand, and we'll go some big dimension. 6, 20, 20. Print out dot shape. This will be Python tensor reshape. There we go. Okay. And then we're going to input 1D. So we can reshape. Oh, interesting. So this will convert every single dimension into a single string. I have been wanting something like this for a long time. I've needed this before, and I've done it manually. Doing a reshape is actually pretty nice. Okay, this is actually really great. 1D, or D1, or 1 dim equals A dot reshape 6 times 20 times 20. Print 1 dim dot shape. All right, like that. There we go. So that converted into a single dimension, or well, yeah, one dimension. So a whole bunch of elements all in one row. And this is what you need when you're inputting data into a system. You need to be able to transform it in your model so that way the input features are captured in a single dimension. Positive humor. Other people seeing Python Snake, then run on other side of Python developer seeing Python Snake, then do print Python. I don't get it. I don't get it. It could be print Python. Oh, because, oh, right. Okay, got it. Yes. You see a real Python in real life, then you use Python to print Python exclamation point. Scary, right? So you do this, right? You say Python. You say print, right? Python exclamation point run, right? I think that's what your humor is. I think that's what you're saying. You're using Python to print that there's a Python to notify other people. Right away, there's Python. I think he means symbolism. Yeah, I'm pretty sure. Yeah, I'm pretty sure. Okay. All right, so this is neat. I like the reshape. What's the difference between view, though? Let's try that. Other dim equals a dot view. Can we do the same thing? Is it identical? Let's find out. Let's see if it's the same. It's exactly the same thing. All right. Do you think our tutorial is gonna tell us? Okay. Dot view and dot reshape PyTorch. Is there a difference? I'm kind of curious about this. We're gonna find out. Okay. Maybe the tutorial will have the answer. Can also call it as a method on the torch module. Oh, torch.reshape. Or on the tensor, you can directly call it on the tensor. Okay. Nice. Still haven't touched the video scripts you sent? Oh, yeah, no worries. Because you know, once I dive in, you'll be working nonstop. Use it as a reference because it's really specifically set up for my workflow, which is going to be very different, I think, than most people's workflows. So it'll be very different. What do you think? I can be a sideman, good joking. Information sharing. What about offering you this, you think? Well, I mean, that's what you're, yeah. Claude, keep on chatting. Happy to have you here. Okay. Which Mac do you use? I have a Mac, a very old Mac. Let's just put it that way. I've got a very old Mac. Thank you, man. Yeah, absolutely. It's very old Mac, but it's good enough. You'd be surprised at how good even old hardware is. OG Mac, yeah, really, really old. Is it Intel based? Yes. That's how old it is. However, it's the last Intel base that's still being supported. So it's the very last Intel that is available and still supported on the latest operating system. Though they did say they're retiring the last Intel, I believe this year or next year. I can't remember. So I'll be stuck on an old version. You guys. Okay. La la la. So Mac 2019 Pro. Yeah, Fizzy, yep, you got it. You got it. Yeah, I was gonna show you, but I don't wanna jostle it right now. I don't wanna disturb it. It's right there. It's right off camera. It's like right there. Reshape will return a view on the tensor to be changed. All right. Let's see. La la la. Transpose, view, and reshape. Often errors works may copy. Oh, okay. That's exactly what Neva said. A transpose tensor classic view may fail because the stride no longer matches the requested shape. Okay. So you can use a reshape and it will always work, usually. And it may do a copy. Often errors. Huh. All right. Well, it was the same for me either way. So apparently you want to use view when you can, because it's going to be guarantee like efficiency, and use reshape when you really, really need it. 2023 version of a Mac, right? Those really newer Macs. Oh wow, you're like new Mac now. You want to get into the new Mac. Any change made to the source? Oh, uh-oh. All right, you guys, we're running out of time. We only got a few minutes left here. Unless you clone it. There are conditions beyond scope of the introduction where reshape has to return tensor carrying a copy of the data. Okay. Then we are on NumPy bridge, and that's it. Okay. Maybe we can do NumPy bridge as the very last thing here. We've got 4 minutes. Can we do it? All right, let's see here. La 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 la. NumPy array np.ones from NumPy. All right, let's do the from NumPy. All right. What we'll do, we'll just do this here directly in the REPL. Torch a equals, oh wait, we got to import NumPy as np, np.array, 2, comma 2. Can we do that? Oh, do we have to do it as a tuple? Okay, there we go. I'm doing live demo of the user flow in your app after you get off. Nice. Feel free to stop by. Consider. Yep. I would love to. I'll try though. I have a meeting that happens literally in 3 minutes, and for the rest of the day, it's like my calendar is blocked for the whole day. Consider it practice for professional video. Oh, nice. No worries. I'll try. If my meeting doesn't happen for whatever reason and we end stream here, then I'll join in. And if you're still going after the meeting, I might have like a good 2 minutes before the next meeting, and I might be able to join in then there. All right, I'll try, Kyle. We'll see if we can make it work. All right, so there's a numpy array. Array. Let's see. Okay. How about, can we do like a random once? Okay, so let's do rand. Can we do that? Okay, we'll do once. We'll just do once. There we go. Once. Perfect. Okay. And then from numpy. All right. So torch tensor equals torch dot from numpy. Like that. All right. And we should be able to just pop this on over here. Copy that directly. Boom. All right. Torch tensor is going to be, oh, and it even already makes it a float 64. Hey, there we go. All right. I'll do a longer stream. Sounds good. Bro, you feel burnout because stream and meeting all day? Managed burnout? Oh, we're good. Hey, we're good. We take a few breaks here and there. Okay. All right. 2 minutes left. 2 minutes left, you guys. Rand. All right. Numpy.rand. All right. PyTorch.rand. And you can bring it into, you can go to NumPy. So you can bring it back. So torch, right? Torch tensor dot. Was it to numpy? No, just NUPY. Like that. And you bring it straight on over, back over to numpy. So you had the tensor to numpy and numpy to tensor. There we go. Making it easy. And then you can use numpy to do that. And you can also do the same thing in torch. You can do exactly the same thing in torch. Torch tensor. 1, 1 equals 5. Oh wait, we got to spell it properly. 1 minute left, you guys. We got 1 minute. We need game stream, Steven. Do more. All right, we might do that eventually. Torch tensor, and then we just retype that here. Boom. Torch tensor allows us to mutate directly, and it allows you to do that in NumPy as well. We did it. We finished the tutorial. All right, so we passed this one. Now we're off to the fundamentals of AutoGrad, and we'll start this tomorrow. The fundamentals of AutoGrad. We're going to learn more details about AutoGrad tomorrow. All right, you guys. 1 weekend per quarter. Come on. Maybe one weekend day per quarter. Maybe. Something like that. We'll find out. That'll be a lot of fun. Okay, you guys. Thank you so much for joining. I'm headed out now. We'll be back tomorrow. We're going to do more Torch, and we're going to do AutoGrad tomorrow. If you've never done AutoGrad, that's when we do AutoGrad. Join us tomorrow for AutoGrad. All right, headed out, you guys. Bye, everyone. See ya, Jen. See ya, Claude. See ya, Kyle. Would be fun. Nice. Thank you. Bye, Fizzy. Thank you for joining in, you guys. We'll be back tomorrow. We'll be early again tomorrow as well. Bye, Anasazi. Good to see ya. All right, guys. See you tomorrow. Bye, everybody.